in this section today. We're going to learn what we call the product rule and the quotient rule. It's all about doing derivatives. So probably by the time this week's over, you'll probably know all the derivative rules there are for me to teach you. Okay, so there's not too many more to do. Okay, so the product rule, what the deal is on the product rule, to kind of start the idea is, I'm going to do this example, and this is super easy to do. If you were doing the derivative of a sum, we have learned this already, that you can do the derivative of each part. Now just write this down, even though that you can do this problem totally in your head. I totally understand that. I just want to demonstrate something to you. Okay, so we have already learned that if you have, three things added, you just do the derivative of each part. That's a rule, okay? So what would be the derivative of 3x? I hope you know that just boom by now. What is that? That's 3. Derivative of 4x is 4, and so forth, right? Anytime you do a derivative of a number times x, the number in front really gives you the slope. So that's 3 plus 4 plus 5, so that would be equal to 12. So we know that's the derivative. Of course, there's another way you could do this problem. The other way you could do this problem is just add the like terms anyway. So if you do 3x plus 4x plus 5x, you're going to get 12x. So if you do the derivative of 12x, do you get the same answer? Yeah, of course. Okay, so that's something we've already learned. Okay, that also works if they were all subtraction symbols. If you had 3 or 4 things all subtracted, well, that's what we learned to do. So now what we're going to look at is kind of investigate the idea of what happens if you have a product. Okay, so my question is, does the derivative of a product equal the product of the derivatives? Well, there's only one way to find out. Let's just try this in a couple of ways and see what happens, okay? So the first thing on this is let's just try to do the derivative of x squared and the derivative of x to the 4th, like we've learned how to do, and multiply them together. And let's see what we get. Then we'll do another way, and we'll see which way we think's right. Okay, so tell me what the derivative of x squared is. 2x. How about x to the 4th? 4x cubed, okay? So if you multiply 2x times 4x cubed, what do you get? 8x to the 4th power, right? Okay. So what you're doing on that, and remember, if you're multiplying variables, you're really adding those exponents, okay? So it looks like we get 8x to the 4th. Okay, maybe that's the right answer, maybe it isn't, okay? Well, let's do another way, okay? Let's see what happens if we just simplify first, and then just kind of do it that way and see if we get the same answer, okay? So what I'm suggesting is if we take x to the 2nd times x to the 4th, again, what is that? The reason I ask that question is a lot of times students think it's x to the 8th. It's not x to the 8th, because see, all this really means, I like, to kind of go off on a little tangent sometimes and remind you of your algebra, but all this really means is this. You don't have to write that down, but it just means I'm multiplying x out a total of 6 times. That's why you add the exponents, because you're just counting how many times you multiply it out anyway, okay? So now tell me what the derivative of x to the 6th is. 6x to the 5th. Okay, we got a totally different answer this time. So something's wrong here. The thing is this way is wrong. Okay, we know the second way has to be right because I did algebra that I know is correct. I know that that's really x to the 6th, and I know how to do the derivative of x to the 6th. So this is the correct way. So it's kind of good to see that when you learn about what we call the product rule in calculus. So the idea is you cannot just do the derivative of each part and multiply. It doesn't work that way. And it never works that way, except maybe a few real special cases it might work, but most of the time it's never going to work. Okay, so what we learn here is what we call the product rule. This is a new derivative rule that we learn, and sometimes you have no choice but to do it. Sometimes you can bypass using it for other reasons. So in symbols, what this says is if you're doing a derivative of two things multiplied, two different functions, f of x and g of x, What you do is you just write down f of x and don't do anything with it. You just write it down. Then you do the derivative of g of x. Okay, then you do it backwards. Then you write down g of x, and then you multiply by the derivative of f of x, and then you add them together. Okay, it's better if you learn this rule in words because you'll remember it better that way. So really the way I look at this is if I have two things being multiplied, then really what I do is I just do the first times the derivative of the second plus the second times derivative of first. And it doesn't matter what order you do that in. It's just you take the first and don't do anything with it, but multiply by the derivative of the other. And you do that twice and add them together. That's what you do. So best way to learn this is just in symbols like this. First times derivative of second added to second times derivative of first. Okay, that's what the product rule is, and you'll use this quite a bit then. Okay, so down on this problem that we just worked out, I want to show you how the product rule would work on this problem. Now, obviously, the best way to do this problem is like we did earlier. You just simplify to get x to the sixth, and then in your head, you get the derivative is 6x to the fifth. Okay, if you encountered that problem, you wouldn't do the product rule, you'd just do that. Okay, but the point is to show you why this works. Okay, so what I'm going to do on the product rule is I'm going to do this. Okay, basically, the first part is going to be the x to the second, and the second part's going to be the x to the fourth. Okay, and when you're learning the product rule, it's usually good to just write down the formula. Okay, so just write down the formula like this. First times derivative of second plus second times derivative of first. Okay, and that's just the way I teach it. I like to just do the first and then the derivative of the second, then do it the opposite way. I like to have my derivatives after the function. Okay, so when we do this, here's how you would set this up. You just write down the first. The first is just x squared. You just write it down. You don't do anything with it. Then what you do is you multiply by the derivative of the second. So what's the derivative of x to the fourth? 4x cubed, good. Okay, then we do it backwards. Now we do a plus sign. We write down the second, which is x to the fourth, and then you multiply by the derivative of the first. So what's the derivative of x squared? That's the first, 2x. Okay, so that's what I did. Okay, so if you look at this, now let's see if we don't get the right answer. This right here is 4x to the fifth, right, because you add the exponents. This part right here is 2x to the fifth. Again, 4 plus 1 is 5. Well, those are like terms, so we get 6x to the fifth. So notice we got the same answer when we do the product rule. Okay, and there's going to be times when you absolutely have to do the product rule. You're not going to have any choice of the matter. Okay, so when you learn it, just learn it in words, not in symbols. First times derivative of second plus second times derivative of first. You use that anytime you see two functions being multiplied. Okay, two functions of a variable in there. Okay, all right, so let's go down to the next page. And really what I want to mention, I'm not going to do a proof on this, but Leibniz, who is one of the co-inventors of calculus along with Isaac Newton, he's the person who figured this out. And guess how he figured it out? By working with that dreaded formula with limit as h goes to 0, f of x plus h minus f of x over h. That's how he figured it out. I don't require you to know that, but this right here is kind of what he did, is he just set up the f of x and g of x into that difference quotient, and now pop the product rule. Okay, that's how that happened. Okay, so that's what a mathematician's doing, is going back to the definition of derivative to figure all these things out. Okay, and it gives us a shortcut. Okay, so you don't have to know that, but if you're interested, you could look at that and see if you can follow through that. I think you probably could, because it's mostly algebra. Okay, so down at the bottom of the page, we're going to do this problem in two different ways, because a problem like this, you might find it easier not to do the product rule. So really, it's going to be your choice on which way you prefer, but you want to see how the product rule works as you're beginning to learn this. So the first thing we want to do is just write down the problem that we're doing the derivative of, and we got to do a little algebra. We have done this before. You're just going to multiply it out. This is, not foiling. It's similar. It's distributive property. So what I'm going to do is I multiply these things out. You can do every bit of this in your head. As I'm teaching this and reminding you of the algebra, I'm just going to write down what I'm doing. Some students who don't do this well in their head would do better if they just write down what they're doing. Okay, so that is 3x to the third when you do that. Okay, then I move to the next thing where I'm going to be doing 3x times 3x. Okay, that is 9x to the second. It's two positive numbers. That's how I know I have a addition symbol in front. So I got that. Then I move on and go to the next thing. I just do 3x times 1. Again, that's two positive, so that's positive 3x. So what I'm doing is just distributing the 3x. Then I'm going to start over again, and I'll do the same with the 4. Okay, so now I do this. Okay, so I'll do negative 4 times x squared, and just bring that down. That's negative 4x squared. Then I'm going to do negative 4 times 3x, okay, which is going to give negative 12x, like that. Then I'm going to do negative 4 times positive 1, which is negative 4. Okay, so I'm just writing down the steps to show you what you're doing in your head anyway. Okay, are there like terms that I can put together? Yep, so you want to do that. Okay, keep it as simple as you can. So 3x the third comes down. I like to just kind of cross things out for myself to let myself know that I'm done with that part of the problem. Then 9x squared minus 4x squared is positive 5x squared. You're just telling me how many of those you have. It's not x to the fourth. It's just how many x squareds do we have? We have 5 left over. Then we've got the 3x and the negative 12x. So 3 minus 12 is minus 9x. And then finally, we got the minus 4 like that. So that's an algebra thing that as a calculus student, you want to be able to do that well, easy, without making any arithmetic mistakes. Okay, now hopefully we're at the point where now we can just figure out what the derivative is in our head. Okay, so what's the derivative of 3x to the third? 9x to the second. Good. What's the derivative of 5x to the second? 10x. What's the derivative of minus 9x? Okay, and what's the derivative of 4? 0, so we don't have to write that down. So if I was doing this problem, this is probably the way I would do this. I wouldn't do this with the product rule, but I'm going to show that to you because you need to know how the product rule works. Because like I said, a lot of times you have no choice. Okay, anybody have any problem with what I did? Yeah. That's if you're not going to use the product rule, you have to multiply it out and then just do your normal derivative. No, the product rule, you would leave the problem alone and then just do it. And that's what I'm getting ready to do. Okay. All right. So here's how the product rule goes. I'll try to highlight this like this. So this, I'm going to highlight, that's the first. And here's the second, like that. And then a good way to start when you learn this is just write down the rule. So first times derivative of second plus second times derivative of first. That's what we're going to do, okay? Now I'm going to write a step that it's kind of, when you learn this, it's good to do the first step this way. So when I get the derivative, dy over dx, according to the product rule, I just write down the first. I don't do anything, I write it down and make sure that's in parentheses. That's important. Then I'm going to write down that I'm going to do the derivative of the second. So I use the Leibniz notation, and then I just write down that I'm going to do the derivative of the second. Now, you'll be able to do that in your head, so you'll be able to bypass this first step. But as we're learning this, it's good to write this first step out. Okay, now I go to the second. and I just write it down. Okay, then I'm going to multiply that by the derivative of the first like that. Okay, so that's what we're going to basically work out. Yeah, the algebra on this problem is going to kind of come after the product rule. So I've got everything set up in my product rule. Now, the next thing I'm going to do is bring the 3x minus 4 down. And again, we're just going to work out these two derivatives. Okay, so the derivative of x squared plus 3x plus 1, what is that in your head? 2x plus 3, good. So we just write 2x plus 3 down. Okay, that's good. Okay, bring the rest of it down. I bring down the second, x squared plus 3x plus 1, like that. Okay, then in my head, I do the derivative of 3x minus 4, which is what? 3. There we go. So see, right there is your derivative. But we need to multiply it out, and we'll see if we get the same answer. Okay, so let's go ahead and multiply all this out now. So what I'm going to do is I'm going to do the FOIL. So I've got 3x times 2x, which is 6x squared. Just do that in your head. I do the outside term, which is 3x times 3, so that's plus 9x. I do the inside term, negative 4 times 2x is negative 8x. And then the last term, negative 4 times 3 is negative 12, like that. Then I'm going to distribute the 3. So I got 3 times x squared is plus 3x squared. 3 times 3x is plus 9x. And then 3 times 1 is plus 3. Now we got a bunch of like terms that we're going to put together, and let's see if we don't get the same answer. Okay. All right. So let's see. We've got the x squareds go together. So 6 plus 3, that would give you your 9x squared. Okay. We're going to put the x's together. So that's going to be 9 minus 8 is 1. 1 plus 9 is 10. And I just scratch them out to let myself know that I'm done with all that. And then the last thing I do is negative 12 plus 3, which is negative 9. Okay, look at that. We got the same answer. Okay. Now, which way do you think is easier, the first way or the second way? Probably most people think the first way is. So you could do this problem this way, but if you prefer the product rule, you can't do it that way too. But again, as we'll see shortly, that in other problems, there's nothing you can do except do the product rule. Like if you have an e to the x or a logarithm or something like that in there, then you have no choice. Okay, so you got to learn how to do the product rule for that reason. All right, is there any questions about how I did that with anybody? Okay, so the algebra is a lot of distributive property, FOIL, that kind of thing like that. Okay, let's go to this next example, which I'll do the same way. Probably by the time Thursday's class of this week's over, you'll have a way to do this problem totally in your head, bypassing both of these methods, something called the chain rule. So the first way I'm going to do on this, and this is probably the way, maybe until you learn the chain rule, that you'll probably do a problem if this pops up. We're just going to write it out twice and multiply it. Then we'll do the derivative, okay? All right, so we're just really foiling that. So we have 4x times 4x is 16x to the second. Then we have 4x times negative 5 is negative 20x. Okay, then I do the inside term. So negative 5 times 4x is another negative 20x. And then negative 5 times negative 5 is plus 25. Okay, got like terms? Put them together. Okay. All right, so let's see. When we put together the x's, we know that negative 20 minus 20 is negative 40x. So we've just multiplied it out, like you do in an algebra class, college algebra, intermediate algebra, whatever. Okay, now we're going to do the derivative. So I'm going to say dy over dx. And again, I think we're to a point where I think something like this, I think we're okay with that. What's the derivative of 16x squared? 32x. Okay, that's all right. Okay, I make mistakes like that too. What's the derivative of negative 40x? Negative 40. And then the derivative of 25 is 0, so that appears to be the derivative like that. Okay, all right. So the product rule's, kind of weird the way it works on this problem because you're just doing the first and second are exactly the same thing. So the first is going to be the 4x minus 5, and the second's going to be the same thing. So just, to kind of practice with this, write down the rule first. So I like to write it down just f times s prime plus s times f prime like that. Okay, so we're just going to do that. And then we'll put this together. So this will go like this. When I do dy over dx, I just write down the first and I don't do anything with it. Then I multiply by the derivative of the second, which you can easily do in your head. But as I'm teaching this, I'm going to, just kind of have you write down what you're doing by using that Leibniz notation. Then we do it backwards. Okay, we do the second, which is 4x minus 5, and this time we multiply by the derivative of the first, which is the same thing. I mean, you can't go wrong on this problem. Okay, so we just do that. Now let's work this out, and let's see if we don't get the same answer. So this is 4x minus 5. We'll come straight down. Okay, now we do the derivative. So what's the derivative of 4x? 4, right? Okay. Then we just bring the rest of it down. So we'll have plus 4x minus 5. And then the derivative of the second part's still going to be 4. So you just get the same thing. So one way you could do this is just do a distributive property. So you'll have 16x and then minus 20. When you distribute the 4 through that, then you go here. This will again be plus 16x and then minus 20. Are you going to get the same answer? Yeah, just put together like terms and you got it. Okay, so 16x and 16x adds up to 32x. And then negative 20 added to another negative 20 is minus 40. So again, product rule on these two examples I did are not going to be things that you're going to do much, probably, unless you prefer doing it that way. I think both of these examples are just as easy to multiply out and then do the derivative. I think that's what most students think. Okay? All right, is there questions about how the product rule is working on that? And just follow the rule, and you want to try to get that memorized. When you get into your second exam, you'll be able to do the half sheet of notes like you did here. But the more of these things you memorize, the faster you can do stuff. Go to your notes and look stuff up. So the product rule, you're going to do it enough that you'll probably get that memorized. Okay, so the next example is one that you don't have any choice but to use the product rule. So what you really have on this is your first is going to be x to the third, and your second is going to be e to the x. So you can't multiply that out. There's nothing you can do. That's as simple as that thing can possibly be. So I'm just going to kind of label this as the first, and that is the second, like that. Okay, and I'm going to just kind of do the same thing. The rule is first times derivative of second plus second times derivative of first, like that. All right, so we'll go ahead and put it together. And you can do this problem totally in your head. There is an algebra piece on this that I want to go through as well. Okay, product rule says write the first down, so just write it down. Don't do anything with it yet, just write it down. Then we're going to multiply by the derivative of e to the x, which we talked about last week. Then we do it backwards. We say plus, then we write the second. And then we multiply by the derivative of the first, like that. So that's how that gets put in. Now, the nice thing about these two derivatives is if you know the rules, you got it. What's the derivative of e to the x? E to the x, okay, right? What's the derivative of x to the third? 3x to the second. Everybody seems to know that. And e to the x, you'll start seeing that all the time, so you'll have that down, I think. So we would have x to the third times e to the x plus e to the x times 3x to the second. All right, now at this stage, we want to go further with this because of what we're going to learn soon. Okay, I don't know, 2 or 3 weeks down the line, we're going to start doing more application with the derivatives. So one of the things you want to get real used to doing is factoring, okay? And you have to know how to factor this and factor it well. So let me just kind of review a few things. Some of the factoring that you encounter in calculus looks different than maybe it did in college algebra. So when we factor this, every time that you factor anything, the first question you ask yourself is there a common factor? You don't just draw two parentheses and start doing it that way, okay? So I'm going to draw a box around the two parts. What do you see that's in common to both boxes? There's an e to the x, right? What else? There's an x in both spots. What you always do is you work with the lowest exponent. Okay, so anytime you take a common factor out, if you have variables to powers, then you take the one with the lowest exponent out. Because if you take the one with the highest exponent out, inside of parentheses, you'd have a negative exponent. You don't want that. So our common factor on this, or we call that the common factor, is going to be x squared e to the x. So that comes out. Now, it depends totally on your skill level as to whether you can do this in your head or not. I'm just going to show you if you struggle doing it in your head, how you can do that. So we're going to take the x squared e to the x out, and it doesn't matter what order you put those two in. It's still the same. So this is something that I recommend for a lot of students, is just write down the previous step directly underneath the parentheses. Okay, and then we're going to figure out what's left after we take that common factor out. So if you do it this way, then it probably makes it a little easier. You don't have to think about it mentally. You can just visually see how this goes. So really all we're doing is we're just simply dividing that previous step by the common factor. Okay, and then you can do this pretty much in your head. So notice on this part, e to the x crosses out. What's x to the third over x squared? X, that's x to the first. Okay, you want to do stuff like that in your head, but x to the third over x squared, it just means that. Okay, two of the x's cross out, so you're left with that. Okay, now you go over here, e to the x crosses out, x squared crosses out, so what are you left with? Plus 3. So that's it. Now, as a student, some students need to do that, some students don't. Okay, so you're going to have to be doing a lot of common factors like that. So you got to have a strategy that works for you. Yeah.
Where did x squared come in?
Okay, the x squared came from the fact that you're looking at the common factor. You know that e to the x occurs in both, but there's also an x in both. So what did I say? You take the lowest exponent out. So that's why x squared came out of the parenthesis. So like if you have an x to the fourth and an x to the sixth, you're going to take an x to the fourth out. Okay? Yeah.
So when we took out the e's or x's, why wasn't one left over?
Okay, because of this, okay, just kind of what I did here. After I divide that previous step by the common factor, see how they both cancel?
Yeah, but like usually when you factor out, you need a placeholder like one.
No, let me also show this to you, okay? Remember, when you factor something, you can check your answer. So check this out. X times x is x to the third, but then we have e to the x. So if you take that times that, wouldn't you just get that? You said okay in your head? If I take this times this, that'll give x to the third e to the x. So there's no e to the x there in the parentheses. Okay? Now you go here, look what happens here. If you take x to the second e to the x times 3, you're going to get this. You got your 3, you got your x squared, you got 3 to the x. So what'll happen, you're kind of used maybe to having something left over. In this case, there's nothing left over. Because what happened is there was an e to the x in both spots. When you took it out, there's not going to be anything left over. Okay, all right? Okay, and usually for students on a problem like this is the algebra part that they have to deal with a little bit. So your final answer on this problem should be the factored form is what I want to make sure you all can get to, because that'll help you for things we're going to do in the future, okay? All right, and try that approach too. Once you figure out the common factor, just divide the previous step by the common factor, and that'll tell you what's left over. Okay, I think that helps a lot of students quite a bit to do it that way. Okay, so what I want you to do next here is two problems. Now, at the bottom of the page, this one I want you to do both ways. I want you to multiply it out first, then do the derivative. Then I want you to do the product rule, and hopefully you'll get the same answer when you do that. And then on the next page, you have no choice on this one but to use the product rule, because that's x to the second times ln x. Okay, I'll leave up the work I did on that part C up there, and go ahead and start working on those two problems and work together and see if you're getting the same answers on that. I'll come around if you need a little help. I think on this first problem, I helped everybody with that to make sure everybody had that right. So, and again, there was algebra issues that you'll get better at over time. And there's a couple of things that I noticed that I want to point out on this is there's kind of a common misunderstanding on things sometimes. And this is something I'm going to write on the board because it's so important. And I can tell that some students that get in the class and they don't really understand the difference. So if you had x squared plus x squared, that's 2x squared. When you add, all you're doing is telling me how many things you have. That's no difference than x plus x is 2x. You're telling me how many x's you have. When you multiply, it's totally different. If you have x squared times x squared, that's x to the fourth. That's when the exponent changes, and you have to understand why. You don't just blindly memorize rules. That just means x times x times x times x, right? Okay, that's what it means. So it's not going to be like x to, so when you do this, a lot of times students see this and they think it's 2x to the fourth, or they think this is 2x to the second. So the only time those exponents change is if you multiply. Okay, you combine like terms, whatever the thing is going to stay the same. Okay, because you're just basically totaling. All right, does everybody have this under control on this? I think I did help specifically every student with that. Now, if I go to the next page, the factoring is the part that's the hardest for most students. So I'm going to go ahead and just kind of put this one together. So the first is the x squared, and the second is the ln x. And by the way, this ln x is one big thing. You can't separate the x from ln. Okay, an ln without an x is nothing. It's nonsense. It's totally meaningless. You have to have a logarithm of something. Okay, you have to. So those two things are married to each other. They're inseparable. So when you do your product rule, which in general I think we did a good job on, you take the first and don't do anything with it. Then you multiply by the derivative of the second. Then you do the plus sign. Make sure you got the plus sign. Then you do the second. And you multiply that by the derivative of the first. Okay, so that's how that goes. Now, when you do this, okay, what's the derivative of ln x? We learned that last week. 1 over x. So now you have x times 1 over x. I'm sorry, x squared times 1 over x plus ln of x times 2x. Now, that's an unsimplified derivative. It's a correct derivative, but you need to simplify it, mostly because of things we do in the future. So from here, the first thing that I encountered was some students not knowing how to handle this part. This part right here, you multiply straight across, you get x squared over x. Okay, and then you have ln of x times 2x. I think most students would understand it better if I put the 2x in front of the ln. And that's a good habit, is to put things in front of an ln. You'll see it better that way. So if you do x squared over x, if you have to write it out, write it out. Okay, that's just x, isn't it? Okay, one of the x's crosses out, so what you're left with is x plus 2x times ln of x. Now, the reason I'm putting the 2x in front of ln x is because I think most students see the next step better if I do. Okay, so that's just kind of something to think about. Okay, so at this stage, that's your derivative. I just want you to factor it. So I draw a box around the two parts. What's the same in both boxes? X. And it's this x right here right here, not the ln of x. The ln of x is not a thing you can do with that, nothing. So what you do is you take that out, you draw a blank parenthesis, and then either you're successful in doing this in your head over time. Students get to a point where they just totally do it in your head. If you're not comfortable with that yet, then just simply take the previous step and divide it by whatever that common factor is. Okay? So here's what happens. What's x over x? It's 1. I see students all the time who just leave a blank there. Okay, it's not gone. X over x is 1. Anything divided by itself is 1. Over here, what happens? That x crosses out, so you're left with plus 2 ln x. So that's your answer right there. That's what I'm after. Okay? Yes?
So you're only taking out the x from the 2x, but not from the ln of x?
Yes, absolutely. It's meaningless. Okay? See, I see this from students all the time. And I don't laugh. Sometimes people will post stuff on this on Facebook, making a joke of students. No, it's a common misunderstanding. That's not right. Okay? All right, there is no such thing. An ln is just nothing. It's nonsense. So you can't do that kind of situation. Okay, so you said that well. It comes out of the 2x. Okay? You mean the ln x over x? There's not a thing you can do with that. No, there's nothing. That's done. That's done. You could write it as 1 over x times ln of x if you want to, but you can't cross those x's out. You can't. ln is in love with x. It's in love with its x. So it kind of sounds funny. Okay, so anyway, those are kind of common misunderstandings that show up. Okay, all right. So let me go ahead and give your test back. Okay, so I'm ready to start with the second part. So the other part of this section, there's only 2 things you learn in this section, is what we call the quotient rule, and which is different than the product rule, but it works kind of basic same idea. So what I want to do on this next thing here is we're going to work with a derivative of a quotient, like a fraction. So let's do this 2 different ways. Let's try this. My question is on here is if I have a derivative of a fraction, f of x over g of x, I'm asking, would it work to just do the derivative of top divided by derivative of bottom? Well, let's find out. So in this example, x to the 5th over x to the 3rd, let's see what happens if we do the derivative of the numerator and divide that by the derivative of the denominator. Okay, let's just try it and see what happens. Okay, so I can tell everybody's pretty sharp on power rule now, at least at this kind of problem. So that's 5x to the 4th. That's 3x to the 2nd. Okay, what does that simplify to in your head? What's x to the 4th over x to the 2nd? X to the 2nd, right, okay. Now, say one thing I've been kind of noticing, and this is common, if you're not sure about your exponent rules, just write stuff out. That's what x to the 4th over x squared means, so you're left with x squared. The shortcuts just do the top exponent minus the bottom exponent. So you would get 5x to the 2nd over 3. Okay, what happens is that cancels out, leaving you a 5x to the 2nd. Okay, so let's try this. So what we're going to do now is we're going to simplify this first. And these are algebra things that you want to improve on so that you don't spend a lot of time on this. What's x to the 5th over x to the 3rd? X to the 2nd. Just do this in your head. Okay, there's 5 x's on top. There's 3 on bottom. How many more are on top? 2. Okay, that's what that problem means. If it's necessary for you, then write it out like on scratch paper or something. X to the 5th just means you multiply x out 5 times. X to the 3rd just means you multiply it out 3 times. After you cancel it, you're left with x to the 2nd. Okay, what's the derivative of x to the 2nd? 2x. So notice we got 2 different answers. The right answer is 2x. This one is wrong, so on your notes, you want to make sure that you loudly somehow say that that's wrong. The point of doing that is to show you that products and quotients don't work that way. You can't just do derivative of numerator divided by derivative of denominator. It doesn't work. in most cases. There are maybe a few cases where it does, but most of the time it doesn't. Okay, so the quotient rule is usually a little bit more complicated looking than the product rule. And then the product rule early in class, every student in here was doing it fine. Okay, it's just the algebra that you're having a little trouble with. Quotient rule is going to look weird to you. So if you do derivative of f of x over g of x, you do g of x times the derivative of f of x. Now it's minus f of x times the derivative of g of x, and it's all over g of x squared. Wow, that's crazy. Well, I don't recommend you learn it that way. There's two ways you can learn this. It's up to you. I like to just do like this. If I'm doing the derivative of the top divided by bottom, just use symbols instead of function symbols, then it goes like this. It's bottom times derivative of top minus top times derivative of bottom over bottom squared. That's the way I do it. Now, some students love this low-D high stuff, and so we do this too. I mean, this is just, some teachers teach it this way. You have the high and the low. So you do low D high minus high D low over low low. Okay? Hey, if that's what works for you, then I'm totally for it. There's even a song on YouTube. I was looking this up and somebody's made that into a song. So if you're curious, go to YouTube and see what it's like. I mean, there's all kinds of things on YouTube. I've seen quadratic formula, like a whole class did the quadratic formula, sung to Pop Goes the Weasel, all kinds of stuff. Hey, whatever it takes. If that's helpful to you, then do that. The way that I'm typically going to do this is just bottom derivative of top minus top derivative of bottom over bottom squared. So the quotient rule, typically students seem to do a good job applying the rule, but the algebra is kind of what you're going to have to work on more. That's very typical. Okay, so there's your proof. I'm not going to spend any time on the proof. That's more or less, if a mathematician goes back to that formula for the derivative, with h goes to 0, out will pop the quotient rule. That's where it comes from, okay? So in this example down at the bottom, I want to show you the easy way and then how the quotient rule works. Then we're going to spend probably the rest of the class just crunching out quotient rule. Okay, so with this problem, we're going to do the derivative of x to the 6th over x to the 3rd. Okay, first of all, learn to think of this way, seriously. There are 6 x's on top, there are 3 on the bottom. How many cancel? 3. How many are left? 3. There's 3 more on top. If you as a student need to do this until you catch on and understand, then just keep writing it out, okay? The reason we learn shortcuts is because if it's x to the millionth over x to the billionth, then nobody does it that way, okay? So anyway, that just gives you x to the 3rd. All right, now if we do the derivative of x to the 3rd, everybody knows this, I can tell today. Everybody's got the power rule down. That's 3x to the 2nd. So that's the correct derivative of that. And if that problem popped up, I'd do it that way. I wouldn't bother the quotient rule. So let's put this in the quotient rule. To begin with, I'd recommend that you just write this down in symbols. B times t prime minus t times b prime all over b squared. Okay, where I'm just kind of thinking bottom and top like this. Okay, so we're going to do this basically kind of like this. So I've got x to the 6th is the top, x to the 3rd is the bottom. So let me show you what happens if you were to do the quotient rule. So you would write down the bottom, which is x to the 3rd. Now let's just do this in our head. What's the derivative of the top, x to the 6th? 6x to the 5th, okay. Now we got minus. Now the top is x to the 6th. And the derivative of the bottom, x to the 3rd, what's the derivative of x to the 3rd? 3x squared. Okay, so it goes like that. So I just do bottom, derivative of top, then a subtraction symbol, and I do it backwards. Top derivative of bottom. Okay, now a good opportunity for another algebra review thing is you do the bottom squared like that. Okay, so first of all, let's kind of see what algebra we know on this. There's one thing that's probably worth reviewing. What is x to the 3rd times 6x to the 5th? 6x to the 8th, okay? What is x to the 6th times 3x to the 2nd? 3x to the 8th, okay? So you're adding exponents. So that's something that you want to know the algebra of your laws of exponents. So that's 6x to the 8th minus 3x to the 8th. Now the bottom, okay? So the bottom, let me ask you a question. Do you think it's x to the 5th or x to the 6th? Okay, good. I didn't hear an x to the 5th. Well, let's kind of remind ourselves why that is. If you have x to the 3rd to the 2nd, the shortcut that you're taught is if you have an exponent, a power to another power, you're taught to multiply the exponents. Well, here's why. First of all, if you square something, squaring something means write something out twice, right? What you're doing is you're writing the x to the 3rd out twice. It means that you have two groups of 3. And by the way, that's what multiplication is. If you have two groups of 3, you're multiplying. So it really just means xxx times xxx. So that's the meaning of x to the 3rd to the 2nd. It's helpful if you understand the meaning behind the math instead of just blindly learning the rules. That's what happens to so many students in algebra. That's why you forget it so much. So this part is going to be x to the 6th. Now the numerator, these are like terms. So 6 minus 3 is 3x to the 8th over x to the 6th. Okay, now this is going to pop up again. I'm not going to write it out this time. I want you to just think. There's 8 x's on top, 6 on the bottom. What happens? 6 cancel, leaving you 2 on top. Then they're on top because there's 2 more on top. So you get 3x squared. Okay, so notice that we got the same answer, the easy way and then the product rule way. Okay, so it's good to show students with an example like that just how the quotient rule works. Now, the product rule, we did some problems where I said you could multiply out first and you wouldn't have to do the product rule. The quotient rule, you almost always have no choice but to use it, okay? So when we go down to this example 2, there's no way to simplify that. The only way that you can simplify an algebraic fraction is to factor the numerator and denominator and see if a factor cancels out. You cannot factor 3x plus 5. You cannot factor x squared minus 3. So all you can do on this is go straight to the quotient rule. Okay, so I'm going to just kind of get these two things put together. Okay, so we're going to have the top is going to be the 3x to the 5th, and the bottom is going to be the x squared minus 3. Okay, now I'm going to write this down. I think when you learn the quotient rule, it's a good idea to just start by writing it down in symbols. But when you're doing homework and stuff, you don't have to do that. I just need to see how it's put in that quotient rule. Okay, so when we do f prime of x, we follow the rule exactly. We write the bottom, so we just write down x squared minus 3. You don't touch it, just write it down. Then you multiply by the derivative of the top, which you're more than welcome to do that in your head, so you could bypass this step. But when you're learning it, I recommend the step I'm writing right now. Now we do minus the top, which is 3x plus 5. Then we multiply by the derivative of the bottom, like that. And then make sure you have a big fraction bar. The whole thing is over the bottom squared, whatever that is, okay? All right, so you get it put in the formula like that. That part right there, students usually thrive with that. You're following a formula, okay? Now, the algebra is what you have to pay the most attention to. We're going to do these two derivatives, and then we're going to algebraically simplify this. Okay, so I've got x squared minus 3 comes down. We know the derivative of 3x plus 5 is 3. You guys seem like you're on top of that now. Then we've got minus 3x plus 5. And then the derivative of x squared minus 3 is 2x. So we got that. Okay, and then leave the bottom alone. One thing that I want to mention on this is when you do the quotient rule, never, ever, ever multiply the denominator out. Leave it square. There's no point in multiplying it out because at the end of the problem, it's possible that if the numerator turned out to be x squared minus 3, then we could cancel a factor out. Do not multiply it out. Don't even bother. It's a waste of time. Okay, so now we're going to distribute. So we got 3x squared is what that is. Then we got 3 times 3 is minus 9. Okay, here's where students slip up algebraically, and it happens a lot. Okay, you got to come up with a strategy to make sure that you do all of this correctly. I find a lot of times students are better on this part of the problem if they put the 2x in front of the 3x plus 5. That's what I find. You don't have to do that, but that's a good way to look at it. Now what you have is negative 2x times 3x is negative 6x squared. You got to have that sign right. Then you have negative 2x times 5 is minus 10x. And it's okay. You don't have to do that. You just process it in your head. All that minus is doing is it's going through that parenthesis. Okay. Then we've got, in the bottom now, we've got x squared minus 3 to the second power like that. Okay. Are we following what I'm doing okay? You do what the quotient rule tells you to do. It tells you how to do the problem. Now, what do you see I can do in the numerator, if anything? Add like terms, absolutely. Okay, so 3x squared minus 6x squared is negative 3x squared. It doesn't matter what order you put these terms in the numerator in. I mean, you prefer to put the highest exponent first. Okay, then we get down to this point like this. Now, when you get to this point here, there's only one thing to consider. And probably you would find if you did 100 of these problems, maybe once or twice, the numerator would factor and cancel with something in the bottom. So you can't forget that maybe you need to do this. What you're going to find on this, if you tried to factor the numerator, it wouldn't factor. And if the numerator doesn't factor, you're done. Okay, so, but you got to remember that every now and then, it's pretty rare that that numerator will factor and cancel with something in the bottom. And that's why you leave the denominator alone. All right, so that's it. That's how the quotient rule goes. That problem right there is not too bad for students. They get badder, they get heavier. That's just the way it is. Okay, does anybody have a question about what I did? Okay. All right, everybody with me and got that down? Okay. Okay, this one's a little badder, but it's still a quotient rule problem. Okay. You have to know this basic rule, which we've learned. We know the derivative of e to the t is e to the t. Okay, that's going to pop up in the problem. So let's go ahead and let's put it in the quotient rule. You don't have to write the quotient rule down every time we do a problem. I'm going to continue to do that because I'm teaching it. So we're going to plug it into that formula. So we take the bottom and make sure that you have the bottom in a set of parentheses. Don't leave that out. Then we're going to multiply by the derivative of the top, which I'll do later. For now, for step one, I'm just going to put it in the formula. Okay. Then I've got the minus sign. Then I've got the top. Make sure you write the top in parentheses. And then you're going to multiply by the derivative of the bottom, like that. And then you're going to go bottom squared like that. So everybody get that written down, and then we'll kind of proceed through the algebra of the problem. What happens on the problem is when we're done with the next step, then you're done with the calculus part of the problem. Okay? So what we need to do is do these two derivatives right here, okay, to get this completed then, okay? All right, so let's see. Let's do this in our head. What's the derivative of 1 minus e to the t in your head? Negative e to the t. The derivative of 1 is 0. Derivative of negative e to the t is negative e to the t. What's the derivative of 1 plus e to the t in your head? E to the t, okay? You like it when e to the t pops up. That's the easiest derivative rule there is. All right, so let's write what we're left with. Okay, so now what we have is 1 plus e to the t in parentheses. It's important you have that, times negative e to the t, minus parentheses, 1 minus e to the t times e to the t over the bottom. What did I say you should always do to the bottom? Let's see if you caught what I said. Leave it alone. Never, ever, ever multiply it out. It's a total waste of your time, okay? So what we have to do now is we have to do distributive property. Now, I'm going to write it this way because I think a lot of students do it better this way, but this is optional. I'm going to put that negative e to the t in front of the parentheses. I think that students are so used to distributing this way then backwards. That's just why I like to show it that way. But if you are confident with distributing from the right, that's fine. That's the way I do it. But let's just do it like that. And then I think a lot of students, like I say, do better if you do it that way. Okay? All right. Now, at this stage, I'm done with the calculus. Okay? And what I find is students usually are fine getting here. Okay? Now, this is where things begin to fall apart sometimes for students. So watch carefully. I'm going to do a distributive property here now. So I've got negative e to the t times 1. Well, that's negative e to the t. That's not a problem. When you go to the next thing, this is where the problem falls with a lot of students. You have a negative times a positive, so that's a negative. But e to the t times e to the t, what do you think that is? I thought somebody would say that, so I asked. That's okay. You're in good company, Roman. Okay? It's not e to the t squared. E to the 2t. E to the 2t. Okay? Now look at what I put on the board here. Here's the thing, all right? If you add exponent, what you do when you multiply, that's when you add exponents, okay? So that's going to be e to the 2t, all right? And you might want to make a note of that because that's real common. You're doing e to the t plus t, so you get e to the 2t. All right, so that's how it goes. Okay, got that? What, are you getting fed back there in the back by the guy next to you? Okay. I mean, you can eat in my class. I don't care. I want people. You can't do a calculus on an empty stomach. But I don't know if I've ever seen the guy next to me feeding them. Okay. Anyway, good enough. All right. So now we go to the next thing. We have e to the t times 1. So that's minus e to the t. Okay. And then here it is again. Negative times positive is negative. E to the t times e to the t is e to the 2t. Okay. So we have that. That's the part of the problem that students are sometimes slip up on, okay? All right, so that's real important. Now, this is probably a good thing to put in your notes, just, loud or something somewhere, because it'll pop up quite a bit. E to the t times e to the t is e to the 2t, okay? And understand why. You're adding exponents. Okay, now if you look at this, it looks like on here that we have like terms that go together. So the like terms that go together are these things right here. I think I may have missed a sign in here too.
Second line, the first one, the second line, it's 1 plus e to t multiplied by minus e to t minus, and in parentheses you need the minus sign in the parentheses.
I'm having a hard time seeing this.
The second set of parentheses, it's supposed to be a negative.
So you
Why
have
minus?
bottom, the derivative of top, minus top. The top is actually wrong side.
This happens to me at least once a semester. It's clear as day what my mistake is to everybody except me. Go ahead. Thank you, Tatiana. Oh, yeah. See, that to me, that's the hardest mistake to catch. You just you change something in the problem. Thank you. Okay, so that needed to be changed like that. And then I need to change. I knew something was going to cancel on this problem, so I knew something was going wrong somewhere. Okay, so that just keeps coming down. All right, so now I think I got it under control. I can't write this thing on here correctly without screwing up. Okay, 1 minus e to the t, and then that keeps coming down, 1 minus e to the t. Okay, now I think I'm in good shape. So what that's going to change then is this will be negative e to the t, and then this thing right here will be plus. Right? Okay, now I'm good. Okay? All right, so what happens is that cancels out. All right, then these are like terms. So you have negative 1 minus one of those. That's negative 2. That's like having negative x minus x, which is negative 2x. So that would be negative e to the t all over 1 plus e to the t to the second. That's your answer right there. Okay, what I made a mistake in is just that kind of mistake where you copy something wrong in the next step of the problem. Okay? All right, that's it. So the big thing that happens on this problem is mostly that e to the t times e to the t thing. Okay, that's e to the 2t. All right, so that's how that goes. All right, any question on that? Okay, now you got to be really careful when you do quotient rule with all of those negative signs that pop up because they're going to happen a lot. Okay, next one is again, I'll do one more quotient rule, then I'll let you kind of work on a few problems and see if we can get this going today. So this time I'm just going to set it up in the quotient rule. I'm not going to write down the quotient rule. You just write down the bottom. Okay, then you multiply by the derivative of the top, which you could do in your head and save this step if you want to, minus the top, times the derivative of the bottom, and then big fraction bar all over 2 plus ln x to the second. Remember I said a couple of times, you always leave that denominator alone, okay? All right, so we got it in the quotient rule. That's generally not a problem for students. Now we just need to get these two derivatives done, which I think we're doing pretty well on that today. Derivative of 4x is 4. What's the derivative of 2 plus ln x? Derivative of 2 is 0. What's derivative of ln x? There we go. Good. Oh, that sounded great. In unison, the whole class. That makes my day. Okay, so we get 2 plus ln x times 4 minus, and then we have 4x times 1 over x, which we saw this situation earlier in class when you were working a problem, all over 2 plus ln x to the second like that. Okay? Now see, you can bypass that first step because you can do the derivative of 4x and 2 plus ln x in your head. Okay, so now what I'm going to do is I'm going to do distributive property, and this time I'm just going to distribute from the right. Okay, so I've got 4 times 2 is going to be 8. Okay, now when you do this, that is plus 4 ln x. There's nothing else you can do. The x, you can't multiply it by x because that's married to that ln like we talked about. But look at this part right here. This popped up once in class today. So hopefully you're a little bit more aware of this. If we have negative 4x times 1 over x, what happens? X cancels. Good. Okay, so you're left with minus 4, right? Okay, we saw that, so that happens. Now we've got 2 plus ln x to the second power. Okay, now what else do you see? Like terms, right? So you want to put these like terms together. So that's going to give us 4 plus 4 ln x all over 2 plus ln x to the second. Okay, now that's an okay answer. One thing I did mention, though, is I said if the numerator factors, it's always worth factoring it. How do you factor 4 plus 4 ln x? Nope, you're thinking 2 parentheses. Is there a common factor? 4, there you go. So common factor is what you always look for. So when you pull this out, you take a 4 out, like that, okay, and then it would be 4 times 1 gives you 4, and then it would be plus ln x. Okay, that's how that comes out. Now the thing on this problem is notice that in this case, these things don't cancel. 1 plus ln x is not the same as 2 plus ln x. So there's nothing else you could do. In this situation, either answer is okay, okay? But the reason I want to factor the 4 out is to remind you that every now and then, if you factor the numerator, it'll cause something in the denominator to cancel, okay? So that's what you want to try to do with that then, okay? Yeah. Make squared.
Yeah.
That's a great assumption. That's always what it's going to be. And you never touch it. You never write it out twice and multiply it. It's all a waste of time, okay? All right, so let's just kind of spend the rest of the class on 2 problems. So number 1 at the bottom, do the quotient rule on that. And then number 2 on the next page has got the E thing in it, So I want you to kind of spend a little bit of time on that. I'll write the quotient rule on the board, and I'll leave this up here. And let's work on that, compare answers, and see if we can get these two worked. Okay, so there's your quotient rule. You need to refer to it. You want to walk around and see how you're doing. What?